Okay, so problem with inverses is, again, let's look at something like sine inverse of square root of 2 over 2, is that there are many things that give me square root of 2 over 2 when I take the sine of them. Because I'm working with the unit circle, and that would be my pi over 4, so right there, it'd be pi over 4, and then I could go around a whole nother time, it'd be pi over 4 again. I could go around a whole nother time, it'd be pi over 4 again. And because it's sine, and sine is just whenever my y is positive, it's actually the pi over 4 here too. And if you remember again with functions, inverses had to be on 2 in order to get an inverse. They could only have one answer. So we only wanted one answer when we took an inverse. So we're going to actually limit the domain and range of inverses, so that way I can have an inverse. So the domain of inverses is already pretty limited. Since I'm looking at what I can get out of it, I can get here my y would be 0. Here my y would be square root of 2 over 2 because at pi over 4 it's square root of 2 over 2. Here it'd be maybe square root of 3 over 2. Here it'd be 1. Highest my sine ever gets to is 1. The y ever gets to is 1. The lowest it ever gets to is negative 1. So inside an inverse, my domain inside so we'll say domain of sine is going to be limited by negative 1 to 1. It's also going to be true of cosine, because cosine is just your x. So here the highest my x ever gets to is 1. Here the lowest my x ever gets to is negative 1. It never gets higher or lower. So my domain of sine and cosine is going to be that. I can only have negative 1 to 1. Tangent is different, and we saw that when we graphed tangent. When we graphed tangent, remember it looked like, and we can look at this with the sine and cosine graph also. The amplitude of sine and cosine is negative 1 to 1. Tan didn't have an amplitude because it kept going down, kept going up. So tan has a domain of all real. So we'll put down here, domain of tan is all real. So let's look at the range. So if I look at the range of y, of sine, again, I can't say all real because I'm going to try to self-limit the range. Otherwise, I'm going to get multiple answers, as we saw with the square root of 2 over 2. I could get this pi over 4. I could get the pi over 4 over here, which would be 3 pi over 4. I could add it 2 pi to this and get 7 pi over 4. I'm sorry, 9 pi over 4. I could keep going, and I get multiple answers. So what I want to limit it to is 1 positive and 1 negative of my answers. And so what I'm going to limit to is, say, sine is positive here and sine is negative here. So if I limit my range just to these parts, then I will cover every instant where sine is negative and every instant where sine is positive. So every answer I could get, that would be a negative 1/2, a negative square root of 3 over 2, a negative square root of 2 over 2, would all be covered just in this range. And I would just get one answer then. So I'm going to say the range of sine, if I look down here, that'd be negative pi over 2 to pi over 2. And that's actually going to be my range of tangent too. So domain of tangent is all reals, range of tangent, negative pi over 2, pi over 2. So here my y's were negative, so sine was negative here, sine was positive here. Here my y's were negative, but my x's were positive, so tan was negative here, and tan is positive here. So for tangent and sine, this covers all my instances. Not true for cosine. For cosine, cosine is x, so that's positive here and here. So for cosine, I'm going to go ahead and extend it over here. So to get all my possible answers for cosine, I'm going to go ahead and say range of cosine. I'm going to go 0 to pi. So my answers out of my inverses, and all these are inverses. So this is range of cosine inverse, range of tan inverse, so forth. So my possible answers out of an inverse have to be between those ranges. my inputs for sine and cosine have to be between -1 and 1. Okay, we'll do a few more examples.